So thanks a lot, Dominic, for this kind introduction. And I also like to thank the organizers of the conference, also for giving me the opportunity to share with you what we have done in the past years. So the broad topic is really actuarial data science. So what I'm going to talk about. So I've structured my talk into 4 main sections. First of all, I'd like to give an introduction to the topic, and in particular where we are coming from. Then I'd like to talk about modeling achievements. Then I'd like to highlight also non-technical aspects on actuarial data science. And at the end, I'd like to give some insight in potential use cases for actuarial data science. So for starting is where I'm coming from. In the Swiss Association of Actuaries, there's a working party for actuarial data science. So we are active since 6 years and we've done quite a lot of work. So if you're interested in knowing much more than I'm going to talk about, here you see the link. Go to the website and have a look for what we have done on that. I'm also very pleased that in many other countries, there are active working groups on the topic of actuarial and data science. In particular, I'm closely following the one in Australia as well. So I think that's really super cool and exciting that we have that across the world. First of all, let me go back one step. So how does machine learning impact actuaries? And I'd like to start with a story or an example that has been shared by Munich Re quite some years ago, but I think it's a good starting point. So Munich Re has a set property claim after hailstorms or hurricanes, and they have done that using new image and machine learning algorithm to estimate the damages in a very short time after such a huge event. And then after some times, they have learned that in particular damages below or hidden in the roofs could not be appropriately estimated based on images. And I think it's a very nice example that shows that even if this algorithm or this tool or this technology is used by the claims, it also has an impact on actuaries. In particular, in that case, the reserving actuaries who had to consider that if you assess the damage of a house just from drone and images from drone, that you need to be aware of that not the full damage of the house can be assessed compared to as an expert on the ground. So in my view, it's a very good example that actuaries, for example, in reserving, are aware of and understand the technology that is used for assessing claims in that example. And this is the link to my first point where machine learning can be used or is used in insurance, and it's exactly claims. So machine learning is used in operation, like in claims, as we have said, to assess claims. It can also be used for triaging claims, or it can be used to prioritize or to underwrite certain risks. So that's very important, and an actuary has a good understanding of it. Then from Munich, it's also known that they offer an Insure AI insurance where really the algorithmic performance is insured. So it really is the core of insurance to insure machine or the risk stemming from performing or non-performing algorithm. Then machine learning, of course, I will talk later about that, can be used really by the actuaries to strengthen the core cell, pricing, reserving, and others. And Lucy later will talk more from a reserving perspective. Another benefit of machine learning, it can help to automate and improve the efficiency of the work of actuaries. And here it's very important in general, it's not machine learning, it's more automation that can help. For example, if you use programming languages like Python and R to streamline the work. And that's a hypothesis that I would like to put here, is that it might be that in the long term, maybe the use of text data for actuaries might have the biggest impact. So with that, I'd like to show that really machine learning affects many different areas within an insurance company, and so it's very important that actuaries have some understanding about the strengths and also the limitation of machine learning. Now, in the remaining of the talk, I will focus on really on machine learning, how it can be used to strengthen really the core skills of actuaries. And with that, I'd like to give you some insights that are really coming from our working group regarding really the modeling component of the actuaries works. So as a working group, we have published 14 so-called tutorials. So those are papers which are really educational papers. It consists of an article where we describe what we do, what is the actuarial application, and it comes with also the corresponding code and the corresponding data which are publicly available. So if you go on the website I've shown before, then you find the link to these tutorials and the subsequent data. So which means it should make you very easy to apply certain techniques. And no worry, I will not go into the details of the 14 tutorials. It just gives you a bit an overview on how really to use machine learning for actuarial purposes. Now I've grouped the tutorials or the achievements that I see in 3 buckets. And the first bucket is really about what are best practices for using machine learning for actuarial applications. And here on the left, I think if you as an actuary have thought to think about to use a neural network, I think we have one of our tutorials is really about how to design and choose the neural network such that it really fits for actuarial applications. So there are certain things that we see that are really a good practice and appropriate for actuarial application, and which are not necessarily appropriate for the usages outside of the actuarial world. So that really should help you in looking into that topics. And then in case you use a black box machine learning model, there are quite a broad range of explainable machine learning techniques. And here also we have written a nice tutorial which shows you what are the strengths and weaknesses of those explainable machine learning tools and which are really useful for actuarial purposes. And one of those techniques are the so-called CHAP values. So we really show for a P&C pricing example how you can use it to really find a very good and well-calibrated generalized linear model, which is often the preferred pricing model. And then coming from our working group, there's a book that has been published. It's open access, so I will share the link maybe afterwards in the chat, where you find a lot more on how really to use machine learning for actuarial applications. The second dimension I'd like to go into is about when you apply machine learning for actuarial application, there are some peculiarities you need to deal with. And the peculiarities are really important because those are things which are specific and dedicated for actuarial applications. And that is really important for actuaries to really consider them, because our learning is, of course, there's extensive literature on how to apply machine learning in retail and in other industries, but for actuarial applications there are some very specific things that are very important, and I think we tried to find what are things that are very important. So on the left side, I'd like to start with an example like we really like and need to have GLM as a references. So there are really ways of how to combine or connect GLMs and neural networks. So that might be quite a good application because we know and like generalized linear models as a baseline. As the second one on the left, that's not from the working group, but very important, is random forest is one well-known machine learning techniques. And if you intend to use it for actuarial purposes, one needs to be very careful about the distribution, because the random forest by default is based on Gaussian losses, which is rarely appropriate for actuarial purposes. So one needs to be very careful in just using a default random forest within actuarial applications. Then what is also a thing to keep in mind is that if you do a pricing or a reserving and you use a GLM, you know that there's no bias. So which means the observed mean is exactly the observed prediction. And this is a property that is very important because from a P&C pricing perspective, it ensures that overall the price, the technical price, is in line with the observation in the past. And when you use neural network or other machine learning techniques, there might be a bias, and so which means you need to correct for that or at least be aware of that. And there are reasons why it's like that, but it's often forgotten. So if you really do a pricing or reserving, you need to deal with this kind of bias. It might be small, but really that's something to be aware of. The one on the right, local GLM data, we don't go further into details. It's a bit similar to how to combine GLMs and really neural network. And the last one at the right at the bottom is about model selection, how you compare machine learning models. And there in machine learning, there's a very, very popular metric that is called the Gini index for comparing models. And yet one needs to be careful for actuarial application to use that, because there's a condition that a model needs to be well calibrated. So which means the predictions need to be aligned with the observed the data or claims, such that you really do it in the right way. And the third one are examples that I call it adds a new perspective on certain topic inspired by machine learning applications. So on the left, so it's, as I've shown at the beginning, so how to deal with images. There are good models around that, and we have shown in one of the tutorials that mortality rates or mortality tables can really be considered as images. And if you consider them as images, then you can really use some of the techniques, for example, to detect anomalies in mortality rate. So really seeing mortality table as images is, in my view, quite a new perspective on certain things we do. And then on the right, we also have looked into the most recent NLP models in order to look at how we can use them for actuarial purposes. So I think that's something I personally believe is something really interesting to be explored, and there has been quite some progress around NLP. I think now everyone knows it with ChatGPT, but already before there were quite some achievements made. So that was an overview on more the technical part, and now let me go into an example on the non-technical part, really about actuarial data science. So on the one hand, this was an initiative from the Actuarial Association, where it's about best practices, how to use machine learning, and yet that's of course not enough or just one perspective. And I'd like to give you an example of a large Swiss insurance group, how if they deal with the updated syllabus, which puts a bit more focus also on data science topics. So there was an initiative in that company sponsored by the group chief actuary with 3 pillars. So one pillar were really training sessions. So it was possible for the actuaries to upskill in R programming, in data science, but also communication, because it was also there were also quite some change in the syllabus. So training session for specific technical or non-technical skills. Then the second pillar was about building a community to learn and exchange. And if you learn programming or data science or data wrangling, it's really good that you have a community within a company where you can discuss the small things that the small challenges that you are facing. It's really building a community. I think that's really also inspired by machine learning open source community, where there are very active communities who really help each other to solve certain technical things. And the third dimension was really about providing the corresponding IT infrastructure for AR and data science, which really makes it very easy for everyone to use within that company. And I think with that, I think there was quite a good initiatives. And the company was following two fundamental principles around this initiative. It was, the first one was really about that to solve concrete challenges of actuaries from their daily tasks. So there were workshops, and really only those could participate who had really a challenge from their daily work they wanted to solve with R or with data science or something similar. And the reason for that principle is really if you as a participant of a workshop want to solve your own problem, then you are much more engaged than just attending a session where you learn R programming. And it really also ensures that the learnings you have from these training sessions, they go back into your daily business. And then the second one is everyone learns the required knowledge hands-on, which means first you start with the challenge you want to solve, then you learn the corresponding knowledge, and then you also get some guidance and support from expert on that. So I think that was a very good initiative. It's not the only insurance group that had such an initiative, but in my view, that is really needed in order to integrate those techniques into the daily activities of the actuaries. Then in the last few minutes, I'd like to give you some impression or a proposal on use cases where these techniques can be used. It's a selection, of course, which is heavily influenced by myself. And one use case, in my view, is really to use free text that we have in P&C and life and health. What I see is that often as actuaries, we either ignore text data or we use some very simple regex approach where we extract words or something like that. And so it's really how to use text data. So concrete applications I list below are really where you have a tabular data, we have quantitative and quantitative columns and features, and there is really a text feature. And with quite limited effort, it's possible to include this textual information for your predictive model. And in the first example, it's really about claims. So there is a short text description about the claim, and then the goal is to classify the claims into fire, flooding, theft, and other types of claims. And with really transformers or good NLP models, that is really an interesting applications where actuaries can contribute. And the second one, this goes back to a data science challenge hosted a few years back. I think it was driven by the Actuaries Institute in Australia and corresponding organization in Singapore. It was a data set with claims, and one column was really a short text description. And so it was really, and the example showed that using the text information really improves your predictive performance on that. The second one is in life underwriting, so where quite some factors are collected, and at the end then there is a decision about if the corresponding risk is going to be underwritten or not. And currently the big reinsurers and insurance company, they have sophisticated rule-based systems, and there is really the opportunity to include machine learning to really make or to help the underwriters to make the decision about accepting or declining the corresponding risk. And the last one, that is a churn analysis or lapsing. You can have that in P&C and life and health. I'm aware of that. Sometimes it's not considered as an actuarial task, but there we see that machine learning can help for really building a good churn model, and yet we also need to be aware of that it's a difficult task with low predictive power, because what influences lapsing can often be not be collected with the corresponding data. And with that, I'd like to reach a conclusion from my talk. So they are the following. So really, statistical learning methods or machine learning allow to fit dependency structures naturally beyond the currently used GLM. And yet a very well calibrated GLM might still be as good as advanced machine learning models in terms of accuracy. And peculiarities of machine learning for actuarial application need to be considered. And I think in the meantime, there are quite some best practices from various actuarial associations around that topic. And machine learning models are more complex, and hence model risk management also needs to address those challenges around them. And with that, I'd like to close approximately on time, and I'm thanking you for your attendance, and I'm open for questions and discussion.
Thanks very much, Jürg. That was a great summary of some of the new machine learning techniques and how they're affecting the actuarial profession. So thanks very much. Just like to remind the audience that they can ask questions at any time through the console, through the site, and I'll be asking any of the relevant questions that pop up. So the first question that I have, Jürg, is machine learning and how you've seen it affect insurance to date. So specifically, what impacts have you observed thus far? Is there more price and risk differentiation that you're observing now compared to in the past? And are there more, say, complex underwriting criteria that are starting to come through? And are things like operations and claims handling processes becoming more efficient due to the deployment of machine learning, such as, for example, image processing?
So thanks a lot for that question. So I understand there are three sub-questions to that. So the first one is about where machine learning impacts in insurance. And in my view, where I see currently the biggest impact is really regarding recording claims, where it can really help to, as I say, to assess better claims and also to change the process how claims are managed from opening a claim to closing a claim. And there are various stages within the claim processing where machine learning, those techniques can help. Secondly, where it can help, where there are very nice applications are in underwriting. There it's more on underwriting side. It's not about the how to come to a decision in underwriting. It's more about avoid manual work, such that really underwriting can focus on the underwriting from a content point of view. And then in the actuarial area, I see it most frequently in P&C pricing, which seems to be the most prominent case where this can be used. In reserving and solvency or capital modeling, I see certain application, but it's by far not as often used and beneficial as for the pricing dimension. And the third part, the third sub question was regarding claims. I think it will continue to change the claims processes, and I think here it's my view that really, in particular, reserving actuaries, that they get an understanding of how it changes the claims processes, and what are the right conclusion to be drawn for, in particular, reserving. So in my view, as a reserving actuary, it's good to have some understanding of machine learning algorithm. For example, if a model is used for claims triaging, and if the algorithm is retrained or changed, this has implication on how the financial figures are flowing within the insurance company. So that's something a reserving actuary needs to be aware of. Now, have I answered all the three sub-questions accurately?
Thanks very much, Jürg. And that was an interesting point you made there, and I think that's a great segue into Lucy's presentation, which is next. I have noticed there's a question come up from Gianpaolo. So he has asked, your point of view, what is your point of view about explainable artificial intelligence in machine learning and your experience about the use of these in practice?
Mm-hmm. So for me, in actuarial application, it's of utmost important that the work is explainable. And so in my view, in most actuarial application, there's a strong preference for interpretable models like GLMs and also in reserving. And so there, what I see as best practice is more that you can use a machine learning model, then you use explainable AI techniques to see how to improve your interpretable model like a GLM. And I see this as a best practice that is established. So it's not machine learning and explainable AI. They are not used for reading the actuarial task, but they're more about how to improve the interpretable and really well-established actuarial methods. So thanks, Clemente, for this, Gianpaolo, for this great question.
Great, thanks. So I don't think we have any more questions from the audience, but I had one additional question. We probably only have about 1 minute or so left. So are there applications for natural language processing and advanced predictive modeling in terms of, say, triaging of claims from workers' compensation or injury schemes? So if we know claims require early intervention or more specialist assessment, do you see this, have you seen this as a potential cost saving and enhancing to claimant recovery outcomes?
So from my personal experience, I'm not yet aware of a company that has really shared with the community that they are already having something like that in production. I'm aware that companies are experimenting with it. So it goes in that direction. And regarding costs, it's very difficult to say. So we will see in the future.
Okay, great. Thanks very much, Jürg.